Hi there and welcome back to chemistry. My name is Jeremy Krug, and in this video we're continuing our lessons on nuclear chemistry. Specifically in this video we're focusing on nuclear transformations. If you're new here, welcome. Check out my channel, check out the playlists, that's where the action is. And if you like what you see and learn something from my video, please smash that like button and consider subscribing. That way you won't miss a thing here on my channel. This is the place for all things honors chemistry and AP chemistry. Now as we go right into nuclear transformations here, you can see that these are basically reactions. These are not chemical reactions, these are nuclear reactions where we have a radioactive isotope that is undergoing a change. Now, what we have here on the reactant side is radon-222. And there's the symbol for radon-222. And we can see that over the course of this reaction, it gives off an alpha particle. Now, we call this alpha emission. When this particle undergoes alpha emission, it undergoes a fundamental change. And sometimes we're asked to calculate what is the resulting particle that this radon-222 atom turns into after it undergoes that alpha emission. So it's our job to figure out what particle goes in this blank space here. Now the concept here is fairly simple. The number on top has to equal out to the same value on both the left side and the right side. So on top, on the left side, we have a 222. So that means that on the right side, it also has to add up to 222. Well, there's a 4 right here. So to figure out the missing number, we just subtract 222 minus 4. And so that means that the missing number on top is 218. So this is just simple subtraction, basically, to solve for the missing number. We have to do the same thing on the bottom. The numbers on the left side on the bottom have to add up to the same thing as the numbers on the right side on the bottom. So we have 86 on the left side on the bottom. So on the right side, it also has to add up to 86. So we have a 2 right here. So all we have to do is subtract 86 minus 2, and we find that the missing number is 84. So those are our missing numbers. 218 on top is the mass number, and 84 is the atomic number on bottom. Now, of course, we have to put an actual atomic symbol in here. Well, we can consult the periodic table and see that the element with an atomic number of 84 is polonium. So I'm going to put a PO right there, and that is the answer. Polonium-218 is the product of this nuclear transformation after radon-222 undergoes alpha emission. Now let's try another example. This one looks a little bit more complex, but it honestly works the exact same way. The numbers on the left side have to add up to the same as the numbers on the right side. So we'll start with the top here. We have 238 plus 1. So that's 239 on the left side. On the right side, we have 233 plus 1 plus 1. So that adds up to 235. So 239 minus 235. What's the missing number? Well, it's 4, isn't it? So I'm going to put a 4 right here on top. Now, let's do the same thing on the bottom. We have 92 plus 0 on the left side. So both sides are going to have to add up to 92. On the right side, we have a 90 plus 0 plus 0. So that's 90. So we have 92 versus 90. What's the missing number? Well, 92 minus 90 is 2, isn't it? So that means a 2 is our missing number on the bottom. Now, what symbol goes along with a 4 over 2? Well, that sure sounds like an alpha particle, doesn't it? So we'll put an alpha right here to show that the missing particle is an alpha particle. So that means that if we bombard this uranium-238 atom with a neutron, we're going to get thorium-233 along with a couple of neutrons and an alpha particle. Let's try another example. Here we have a carbon-14 atom, and it looks like it's undergoing some nuclear transformation by which it becomes nitrogen-14. So let's figure out what the missing particle is here on the line. Well, on the top, we have 14 on the left, and we have 14 on the right. So 14 minus 14 is 0. So 0 is our missing number on top. We do the same thing for the bottom. We have 6 on the left side. We have 7 on the right side. What's the missing number? Be very careful. 6 minus 7 is -1, isn't it? So that should be a -1 that goes there on the bottom in our missing particle. Now, what is the symbol that goes along with 0 on top, -1 on bottom? Well, you might remember from a couple of videos ago, we said this is a beta particle, isn't it? So we're going to put a beta right there to show that this is a beta particle. Or if you prefer, you can write an E there as well, because 0 over -1e is also a good symbol for a beta particle. Let's try one more example here with nuclear transformations. We'll try this one right here. This time we have an atom of curium-246 being bombarded with an atom of carbon-12, and looks like one of the products is an atom of nobelium-254. And our job is to figure out what is the missing particle there on that line. So it's same process, same concept here. On the left side on top, we have 246 plus 12. So that's 258. And on the right side on top, we have 254. So 258 minus 254 is 4 on top, isn't it? So we'll put the 4 there on top. Now on the bottom, on the left side, we have 96 plus 6, which is 102. And on the right side on the bottom, we also have 102. So what's the missing number? Well, 102 minus 102 is just 0. So we have 4 over 0. Now, what is this? Because some students see a 4 over 0 and they get confused because of all these types of ionizing radiation and particles that we've learned about, we don't know of anything that's a 4 over 0. So some students get confused by that and wonder what's going on here. Well, we don't know of anything that's a 4 over 0, but I do know of something that is a 1 over 0. And we call that a neutron, don't we? So maybe what we have is not just one neutron, maybe we have 4 of those neutrons. That would make sense, wouldn't it? 4 neutrons would give us a total of 4 particles on top and 0 particles on bottom. So that is our answer. The fact is this is not just one missing particle, it's actually 4 particles, 4 neutrons. So that's kind of a tougher example if you see something like this. Hey, I hope you learned something about nuclear transformations. If you did, please slam that like button. I would really appreciate it. That helps the algorithm and helps get my videos out to other great chemistry students just like yourself that want to learn about nuclear chemistry. In my next video, we're going to take a look at some other applications of nuclear science involving fission and fusion. I hope to see you in that next video where we can learn some more chemistry together.